This workspace is about modeling the motion of a free particle. You see lots of building blocks. Number 5 on the upper left catches your attention. Full of curiosity, you right-click and inspect it. Number 5. Next, you look at number 4. You multiply 5 and 4. You wonder if 2 plus 5 times 4 works. Indeed, 22. Next, the block up. Looks interesting. An unknown type. This block does not seem to mean very much, but noticing its two connections, you attach the formula you just created. You read the type of the result, column vector, but there are no columns. You connect the number 3. At last, a proper column vector in 2 dimensions. A block called time is nearby. Certainly, a time-dependent vector would be nice. You inspect time. An error. It reads could not resolve symbol. Obviously, the time block must not be by itself. You connect it to the defen block and inspect again. An error. It reads could not resolve symbol. Now you notice the path of a free particle block. You connect it and inspect the defen block. A cryptic output without any type at all. You realize from prior experience that you just created a stub for a function definition. The name of the function is path of a free particle and its argument is time. You add a block 4 times time to the last connection of the defen block. Cryptic output without any type at all. This is expected, as you know that functions need to be called. You right-click on empty space to open the parser and create the call statement. The error is because a time block is still unconnected. For now, move the block path of a free particle 10 upwards so that it is called before the error occurs. You are pleased to finally get some number. Inspecting time, the argument of the function just called, seems interesting. Time is also a number, but you suspect that it could be something else as well. Remembering the hint button, you press it twice after opening the parser. This is yet another new type, an expression. Now you start to finish the free particle motion. A vector of numbers. Calling the function with a symbol is certainly more interesting. Finally, the time-dependent vector. You inspect the argument time of the function again. The block changes type during the course of the program. It is first a number, then a symbol. You notice a button below. You came a long way to this final result. Maybe you skipped a few steps. Running this workspace yields the equation of motion for the driven pendulum. Inspecting the block height of pivot time demonstrates another very general result. Blocks change their type during the course of the program. Height of pivot can be of type differential as well as of type expression. You wonder what differential means in this context, and you search for numbers, as those connect the theory to experiment. But they seem to be quite elusive here. Nevertheless, you hope to recover more numbers in future quests. For now, you have reached the end of this one.